definite integral. A definite integral is an integral of this form. This is what we mean by definite integral. Before, we have been dealing with integral of this format. That is what we have been dealing with. There's nothing here. But when we have values here, a and b, then it is called definite integral. These values are called the boundary of the integral. They call it the boundary of the integral. Now, by definition of this thing, if you have that g of s is the integration of f of s, that is, if I integrate this and I will get this, then if there's a value here, the answer will be g of b, that is, we put s to be b, minus you put s to be a inside this answer that you got. If you take example, let's assume that we want to integrate this 2 to 4 2s plus 1 dx. All we need to do is to know how to integrate. If you have known how to integrate, then this thing has no any work. If I integrate this, I will have s squared, which I have taught you. I don't need to do that. If I integrate 1, I will have x. Then I'll put 2, 4. What this thing now means is that anywhere I see s, I'll put it as 4. That will be 4 squared minus anywhere I see s, I'll put 4 again. That is for this. I will now say minus anywhere I see s, you can see g of b. Our b is the lower boundary. This is the upper boundary. Anywhere I see s, I'll put it as 2. This will now be 2 squared plus 2. So this is 16 plus 4. That is 20 minus 4 plus 2, 6. Our answer is 14. So that means the value of this integral is 14. Now, let's assume that we want to consider another integration. Let's say we have 1 to 3. And we want to integrate 2s squared plus 3s plus 1 dx. Just know how to integrate, that is all. When we integrate this, I will have 2s3 over 3 plus, if I integrate this one, I will have 3s squared over 2 plus, if I integrate 1, I will have x. That will be 1 to 2. Anywhere we now see x, we will put it as 2 in this final integration. This will be 2 into 2 cubed over 3. You know, we normally put plus c, but under this one, we don't need to put plus c because at the end of the day, c will leave. So we don't need plus c. Plus this one, I will put, this is 3 squared over 2 plus, this one will be what? 2 minus, anywhere I see s, I will now put it as 1 minus this boundary. That is 2 into 1 cube over 3 plus 3 into 1 square over 2 plus put s as 1 plus 1. So I will leave this for you to do. You simplify this and you simplify this to get your final answer. If I have another one, let's say I want to integrate 2 sin x ds from 0 to pi. I want to integrate it. To integrate this, we know the integration of this one to be minus cos x. So we say 0 to pi. Let me put the minus 2 out. And you know what this thing means is that anywhere I see s, I'll put it as pi. That will be cos pi minus anywhere I see s, I'll put it as 0. This minus 2 is outside there. Minus cos 0. But the question is, what is pi? In this place, pi is representing 180 degrees. So that means we are dealing with cos 180 degrees. So if you use our calculator, cos 180 degrees will give me minus 1. Then minus cos 0 will give me 1. This is minus 2 into minus 1 minus 1, that is minus 2. So our answer is 4. So that means the value of this integral is 4. So that is that about definite integral. You only need to know how to integrate. And if you consider more complicated one, let's say we have 2s into 1 plus s squared raised to power 3 dx. Let's say we have 0 to 1. 0 to 1 as the integration. Now, all this integral we have done before, we observe that if you differentiate this one, we will get this one. In that case, we use integration by substitution by saying let u be 1 plus s squared. When we differentiate the u dx, that will be 2x. If you make the extra formula as we normally do, that will be du over 2x. Don't forget that we are using integration by substitution. You have to change this boundary too, because these boundaries 0 and 1 are meant for x, and we are changing it to u. So we only need to say we change the boundary like this. If x is equal to 0, because s is 0 here, our u will be equal to, anywhere I see s, I'll put it as 0. This is 1 plus 0 square. So u will be 1. So in this case now, this boundary will turn to 1. I will change this boundary too by turning s to u. I will say if s is 1, so this thing is what I will be using. U will be equal to 1 plus 1 square. That is 2. So in that case, the integration, let me use I for it. The integration will now become 1 to 2. You can see 0 to 1 has become 1 to 2. Now let's come to this place. As we normally do, 2x. This one is, we have said this is to be u. This is u cube dx. Our dx is du over 2s. So this cancels this. What we have left is 1 to 2 u cube du. I can now integrate this. U cube will be u raised to power 4 over 4. 1 to 2. So anywhere I see u, I'll put it as 2. So that will be 2 raised to power 4 over 4 minus, anywhere I see u, I'll put it as 1. That will be 1 raised to power 4 over 4. 2 raised to power 4 over 4. This is 16. That will be 4 minus 1 over 4. And that should be 15 over 4. That means the value of this integral is 15 over 4. Now let's consider this example too. It's another complicated example. But don't forget that I've taught you integration of something of this nature. This is integration by trigonometric substitution. What do? We say let x be equal to 2 sine theta. You can still remember. Now, we start by saying let s be equal to 2 sine theta. How did you do that? Why did you do that? Because 4 here is 2 squared. So that at the end of the day, it will, if I use 2, it will eliminate this x. From that place, I will differentiate dx. If I differentiate this, I will have 2 cos theta, then d theta. From that place, I need to change the boundary too. I will need to change this boundary. If I come to this place, theta here will be equal to, or let me put it like this for better understanding, sine theta will be equal to x over 2. If I make sine theta the same formula, then theta will have become arc sine x over 2. Now let us use this. If x is 0, this one, just like what we did the other time. If x is 0, theta will be arc sine 0 over 2. If you use your calculator, our answer is 0. If x is 2, this one, our theta is arc sine 2 over 2. This is arc sine 1. But arc sine 1, that is, what will give me 1? What sine will give me 1? Is 90 degrees. When you use your calculator, sine 90. But 90 degrees, you can't leave it like this because you are dealing with integration. You have to leave it in radian. How do you express it in radian? Just know that pi is 180 degrees in radian. So in that case, if I divide it by 2, that is where I will have 90. 180 divided by 2 is 90. Definitely, pi over 2 will be equal to 90. So our 90 here will be pi over 2. That will be meant for this integral. The integral will now become 0 to pi over 2. 0 to pi over 2, square root of 4 minus x squared. S squared, this is our s. S squared will be 4. That is 2 square, 4 sine square theta. 4 sine square theta. Then the next one is dx. This is our ds. 2 cos theta d theta. So this one becomes 4 is common. So we have 4 into 1 minus sine square theta, 2 cos theta d theta. This will be 4 is, we can find square root of 4 to be 2. Also, 1 minus sine square theta, we recall that 1 minus sine square theta, we have known this is equal to cos square theta. So this one is cos square theta. And the square root of the cos square theta will give me cos theta times another cos theta. So that should now become 4 cos squared theta d theta, because they are in two places. 2 times 2 cos times cos. That is cos square theta. Now, how do we now integrate this? I have taught you how to integrate cos square theta. But if you don't remember, you use this formula. You recall this formula, which I have explained before. That is half into 1 plus cos 2 theta. If you can still recall, half into 1 plus cos 2 theta. From that place, our integral will be, because this cos square theta will become half into 1 plus cos 2 theta d theta. So this cancels this. What we have left is 2 into, I can now integrate 1. If I integrate 1, I will have theta. We are not dealing with x, it will have been x. We are dealing with theta. If I integrate cos 2 theta, I will have sine 2 theta over 2. Then we put the boundary there, 0 to pi over 2. This is 2 into, anywhere I see theta, I'll put it as pi over 2. This is pi over 2 plus sine 2 into pi over 2 over 2. Minus, I'll put theta to be 0. This is 0 plus, to become minus, sine 0. Sine 0 over 2. But without stressing yourself, all this 0. 2 cancel 2 here. It will mean pi. And I said here that pi is 180. So using your calculator, you find out that sine 180 is 0. Sine 180 is 0. So what we are going to have left is 2 into pi over 2. And they will cancel each other. So our answer is pi. So our answer is pi. That is our answer. So you can try this. You can, or you should try this. Let's say we are given 0 to 1, square root of 1 plus s squared dx. So int, so you let x to be tan theta, you differentiate, the x is sec square theta d theta, and we differentiate, make tan theta the zero formula, that is make theta the zero formula, theta will be arc tan x. Then substitute this boundary. If x is 0, theta will be arc tan 0, that will be 0, theta is still 0. If x is 1, this 1, theta will be arc tan 1, but arc tan 1 will give me pi, or let me say 45 degree. And since you have known that pi is 180, we just need to express 45 in terms of this, which will just give me pi over 4. Then the integral will now become 0 to pi over 4 into root of 1 plus s squared. Our s is tan. This will be tan square theta dx. These are dx here. Sec square theta d theta. These are dx. But 1 plus, we have done all this before. 1 plus tan square theta will give me sec square theta. And the square root will give me ordinary sec. In that case, what we are going to have is just sec times sec to be sec cube. Or we can say that sec theta sec square theta d theta. Now, so the rest is left as exercise. And I've done something like this in our previous videos. So you can check the last video under further integration. The last video. So you can check it, you see the integration of this. So to finish your answer. Now considering application of integration. Firstly, we'll talk about area under curve. Area under curve. If you consider this this graph, let's say this is a graph f of x. If you have point x here, which is A, and we have another point x here, which is B, can we find the area of this shaded region? That is one of the applications of integration. So the formula is this. Area is simply absolute value of f of x ds a to b. That is integration of this function from the boundary of a to boundary of b. Now, when we are dealing with area under curve, we need to know how to draw the curve, because it is very necessary when it comes to this concept. But let me just give you a hint. If you are given a quadratic function, at least you can still know this. If you are given a quadratic function as squared plus bs plus c, you are given this. We normally say that this quadratic function has minimum. I've taught you minimum if this a is negative. Sorry, if this a is positive. But if this a is negative, we say that this quadratic function has maximum. So that means if I have something of this nature, s squared minus 3s plus 2, it is minimum because there is positive number here. Since it's minimum, I can draw it like this. It will go like this. That's how to draw the... I'm just explaining how to sketch the graph for you. But if you have something like this, 2 plus 3s minus s squared. Because there's minus here, it is maximum. If it is maximum, they draw it like this. And it's very, very important. And this is the function we are talking about. This is the function f of s. Function f of s. To find the area, we just say a to b, integral a to b, f of s dx. Now let's take an example on this. Let's take this example. Find the area bounded by the graph of this function and the axis on this and on this. Now solution. Before anything, we must first know how to draw this graph. And how do we know it? I've explained this the other time, but we need to know the point at which this curve cuts the x-axis, and that is simply solving this quadratic equation. Let's solve the quadratic equation to know where this curve touches x-axis. So if you solve the quadratic equation, we will see that our s is -1 or s is -2. So we have known that. I can now sketch the graph. Let us just sketch the graph. Remember, we have a minus here, sorry, we have plus here. It is minimum, so it has to go like this. And also I have -1 and -2. We should know that there is -1 here. Let's say there is -2 here, so this is where the function will be. Since it's minimum, it will go down like this. Now the first one says -1 to, you see that, you know that we have two sides here, this side and this side. When we have the function at this side, then the integration becomes positive. But when it jumps to this second side, the integration becomes negative. Now the first question says we are dealing with -2 to -1. That is from this place to this place. So this is what we are looking for. This place to this place. In that case, area is -2 to -1 f of s ds. This is -2 to -1. This is our f of x. That is s squared plus 3s plus 2 dx. So I don't need to teach you this. I'll just give you the final answer. So when we do it, you are going to have 1/6 units square. You should be able to do this. Now for the second one says -2 to 0. You know, this place is 0. -2 to 0, we cannot jump to -2 to 0. I'll first take it from -2 to -1, then -1 to 0. This is what we are looking for. Then -1 to 0. So the area there will be though it is -2 to 0, but there is an obstacle here which stops as -1. So I'll say that -2 to -1 f of s, then -1 to 0. And what that means, we have done this. This is it here. 1/6 plus -1 to 0 f of s. This is our f of s. S squared plus 3s plus 6 plus 2 dx. I don't need to show you these two. I only need to explain how to get it. So when you do everything, so this should give you -1/3. By the time you do it, 3/2 minus 2. So everything will give you 1. So that is 1 unit square. So you should be able to, now you solve this and add it to it, and add it to 1/6, you should get 1. So that is that about that. Let's take another example. Our example 2, calculate the area bounded by the graph of this function and the axis on -3 to 3. Now before anything, we need to know, you know, this, there is positive s square here. So in that case, it is minimum, it will go down. But let us know where it touches x-axis. So we need to solve this quadratic equation. And solving it, this is s into s plus 3 is equal to 0. Therefore, s is 0 or s is -3. That is, it touches x-axis at 0 and -3. So if you sketch the graph, 0 and -3, this is 0. It will pass this place. This is 0. This is -3. Let's say this is 3. Because the question says it will be from -3 to 3. -3 to 3. But there's an obstacle here which is 0. You observe that this one goes down to be negative. Because I told you when it goes down, it is negative. So we are moving from -3 to 3. So it will just be minus 3 to 0, then 0 to 3. The area will be, I will say minus, because from minus 3 to 3, it comes to the negative y-axis. That is why we put minus here. And that is the reason why it is very necessary to know how to draw the graph. So that will be minus 3 to 0. That's our f of s squared plus 3s ds, plus the next one 0 to 3. 0 to 3, the function s squared plus 3x ds. So we need to, I don't need to, I taught you all this, so I don't need to stress myself further. But when you finish it, you should be able to get 27 as your final answer. Let's consider another example. Number 3, calculate the area bounded by the graph of this and the axis on this point, minus 2 pi to 2 pi. Area of sin x. You need to know how to draw the graph of sin x. That is very, very important. And if you don't know that, you should go and learn it, how to draw the graph of sin x. This is graph of sin x. This is how it looks like. In this case, there is 0 here. Here, there is pi here. Here, there is 2 pi. That is how graph of sin x is. Here, there is minus pi. Here, there is minus 2 pi. But which area are we looking for? We are looking for area of this from minus 2 pi to 2 pi. That is from this place to this place. We are looking for this area, this, up to this place. In that case, the area is, it will start from, this side is on top, is positive. I will say plus. This is minus 2 pi to minus pi. The function is sin x. Don't forget this one, this side is negative from minus pi to 0. So I will say minus, this is minus pi to 0, sin x dx, plus, this one is plus, it's on top, plus 0 to pi, sin x ds, this is the function, plus, sorry, it will now be minus because this one is negative, it's on negative side. Minus pi, sorry, pi to 2 pi, sin x dx. So that is that about that. And you know what integration of sin x is. The integration of sin x simply means minus cos x. So you put this value. Just take note that pi is 180 degrees. So by the time you finish solving it, you are going to get it as your final answer. Also, calculate the area bounded by the graph of this and the axis on minus 1 to 1. I want to calculate the area bounded by the graph of this function. Now the first thing is, let us first solve this question. This is s cubed. You see that s is common. It will remain s squared minus 1 is equal to 0. Therefore, s is equal to 0 or s squared minus 1 is 0. Without stressing myself, s is 0, s is minus 1, and s is 1. Those are the ordinates. We now need to draw the graph. 0 is here, 1 is here, minus 1 is here. So when you draw the graph, it will be like this. It will pass through this 0. It will come like this. How do we even know that it comes like this? Why can't I draw it like this? You need to know the minimum and maximum of this function, which I have taught you before. If the minimum is negative, then on this one, it will come down. If it is positive, you need to test the minimum and maximum on this 1, 0, and minus 1 to know which one goes up and which one goes down out of the two. This I have taught you how to find the minimum and maximum. That is that about that. Now, we cannot find the area. Area is, we are looking for minus 1 to 1, s square, s cubed minus x dx. We are looking for minus 1 to 1. But there are obstacles. So it will just be minus 1 to 0, this place to this place, s cubed minus s ds. But don't forget that this one passes through the negative side. Instead of plus, it will be minus, it will now be 0 to 1. 0 to 1, s cubed minus x dx. So we now need to solve this, and we need to solve this. But I don't need to show you that. By the time you solve it, you should get 1 over 2 unit square. So that will be our answer. So you should be able to finish this. Let's consider area bounded by two functions. This is what we are trying to say. Let's say we have a function f here. This is f of x. And we are having another function g of x. We are having another function g of x. This is function f of x. The question is, can we find the area between them? So the formula is this. Area is equal to, it will be, let's say they meet at point A and B. It will be A comma B. That should be f of x minus g of x dx. Then we are having two functions. It will be f of x minus g of x. Why do we say f? We pick f before because f is on top. This is a line of f. So the one that is on top will come before the second one, so that you will not be getting negative. And if you get negative, just neglect it. Now let's take example. I have example here. Find the area bounded by the graphs of this function and this function on this point and on this point. The first thing is, let us draw the graph of this function. For the first one, this is s into s plus 2 is equal to 0. Therefore, s is 0 or s is minus 2. Okay, it moves to the next side here. This is 0. This is minus 2. And it is minimal because there is positive here. So definitely this is how it will go. Also, the second one, this point here, if I draw it, if I bring it here, I will have s is equal to 4. If I bring this one here, if I divide both sides by 4, I will have y over 4 plus s over 4 is equal to 1. So this simply means that it's a straight line. Normally it's a straight line, and it passes through 4, and it passes through 4 at y and passes through 4 at x. So this is what it means. 4. Let's say this is 4 as well. So the straight line will be here. Don't mind my drawing. It's just a sketch. Let me put the 4 here. They will join. Let me put the 4 here. This is a 4. They will join here. The question now is that what are we looking for? Minus 4 to 1. We need to know this place where they join. This place. What is here to this place? What is it? This one too. Where they join. What is it? I will need to solve these two equations. We have s squared plus 2s. We will see that it's equal to minus this. We want to know where they join. So if this one comes in, we have s squared plus 3s minus 4 is equal to 0. If s comes in, so this will lead to quadratic equation. And we will now need to solve the quadratic equation. When we solve the quadratic equation, we have that s is 1 or s is minus 4. So s is 1 or s is minus 4. So definitely we should know that 1 will be here. This is 1. This place is minus 4. What are we now looking for? Area from -4 to 1. This place, from this place to this place, -4 to 1. So the first one, area. Don't forget that since there are two functions, it has to be negative. You observe that from -4 to 1 there are obstacles. So the area will be, I will say, -4 to, there's an obstacle here, to -2, because there's an obstacle there. Okay, sorry, to, this is to 1, -4 to 1. This is not an obstacle because it's just one function. We are dealing with these two, so it's very straightforward. -4 to 1. Let's say -4 to 1. But within this -4 to 1, you observe that this point, this straight line, is on top. So, and that straight line is this one that we found there, -s plus 4 minus this small one, this curve. The curve is s squared plus 2x dx. So it will now be -4 to 1. If you expand this, it will give you minus x plus 4 minus s squared minus 2x dx. No, this one, when we bring it together, it will be -4 to 1 minus s squared minus 3s plus 4 dx. So we now need to solve this integration. By the time we solve the integration, it will give you 125 divided by 6 unit square. So this is the final answer for this integration. But for B says we should solve it from -4 to 2. -4 to 2. Without stressing ourselves, we should know -4 to, this is to 4, or -4 to 2. Let's say this is 2. So it has joined this place. We are dealing with the whole of this place and this one, so there's an obstacle here. So -4, A is -4 to 2. That will just be -4 to 1, then 1 to 2. That is how it will be because there's an obstacle there. We have done this one to be 125 divided by 6 -4 to it will remain 1 to 2, 1 to 2, 1 to 2. That is between this place and this place. But don't forget that on top here it is the curve. This curve is on top, unlike this one that the line is on top. It is this curve that is on top. So this one will be s squared plus 2s minus the line. This is a line, minus s plus 4 dx. Can see it. From that place, our area will now become, okay, we have done this, 125 over 6 plus 1 to 2. That will be s squared plus 3s minus 4. S squared plus 3s minus 4 ds. So we need to integrate this one too and add it to the second one. So by the time we integrate it and add it to the second one, we have 71 over 3 unit square. So that is our answer. So the solution once again, you can see it. You can check the solution once again. So check the graph in the textbook. This is the graph. They understand it very well. The area of the region bounded by the graphs of parabolas this and this. We need to sketch it. That's the first thing. We need to sketch. If you don't sketch, we can't solve this question. The first one, y square plus 4s. This is the graph of that one. This is graph y square is equal to 4s, or we can say that y is equal to square root of this. That is 2 root x. You can make y the same formula. But this one, s square plus is equal to 4y. This should be the graph. You know, this is graph s square is positive, and it only has this thing here. So this is graph s square is equal to 4y, or we can say that y is equal to s square plus 4. The question is that we know that it meets in this place. It will also meet in this place. But the question is, what is this point? Let's substitute this one. S square over 4 equal to, we substitute this one, 2 root x equal to this. That's how to solve it. If you cross multiply, s square will be equal to 8 root s. If you square both sides so that we can remove this square root, this will be s raised to the power 4 is equal to 64x. Without stressing yourself, you see that s is 0, or x is, you can see if you divide both sides by s is 64. That is, s is 4. So from that place, s is 0 or s is 4. Definitely what is here is 4. So what is here is 4. So in that case, I cannot find the area. The area would just be 0 to 4. 0 to 4, something minus something. The one on top. This is the one on top. The one on top is 2 square root of s minus the one down, which is s square over 4. S square over 4 dx. So this is what we now need to solve. So, and I don't need to teach you this. So we need to find the integration of the function. And when you find the integration of the function, you should be able to have 16 divided by 3 unit square. So that is the answer. So volume have explained area. We now need to move to volume of a shape. How do you find volume of a shape? Using integration. So this is it. Volume of solid of revolution. What do we mean by solid of revolution? You see, when a point is moving in a plane, that is when it's rolling. Let's say that, let's take this straight line now. This straight line, when it's rolling, either to x-axis or y-axis. Let's say when it's rolling like this, definitely the rolling will be here. The line will still come here. You see that it forms this shape, which is called a cylinder. So when a point is moving in a plane, or well, let's say when a curve is rotating in a plane, it used to form a solid. It will form a shape which is called a solid, and that solid is what we call a solid of revolution. We call it solid of revolution. When it's moving in a plane, we call it a solid of revolution. Now we are not dealing with volume of the solid. So when the curve this rotated about x-axis, or is revolved about x-axis, the volume is given as pi a to b y square plus s. This is when it's rotated about x-axis. Just know that y simply means our f of s, just like what we have here. And when the curve rotated about y-axis, the volume is given as pi into a to b s squared dx. So we say that s is g of y. So that is that about that. S squared dy when it's rotated about y axis. Now let's take an example. Find the volume of the solid generated when the graph of this sinus revolves about x-axis on s is equal to 0 and s is equal to pi over 2. Normally, if you draw graph of sin s, I've drawn it the other time, this is what you are going to have. I told you this place is pi. Definitely pi over 2 will be here. So we are dealing with this place. So if it's revolved, that means it's rotating about x-axis. They said it revolves about x-axis. That is from this place to this place alone. You should know definitely it will come like this too. It will come down when it's rotating. It will form a circle here. To form a circle here. So this place is pi over 2. So this is the volume of the shape we are looking for. So that is the volume of the shape. So the volume is pi into, since it's rotated by x-axis, from 0 to pi over 2. So it is pi into y square dx. So this is our y square. This is our y. So this is our y. So our answer is pi into 0 to pi over 2. Our y is sin s. So that place will be sin square s ds. And I've taught you how to integrate sin square s. I'll use the formula. This says sin square s is 1 over 2. This is the half here. 1 over 2 into 1 minus cos 2s ds. So from that place, the volume, once again, see it so that you can pause it and write it down. Volume will now be pi over 2 into, if we integrate this, we have x, and if we integrate cos 2s, so we have x. If you integrate cos 2s, we have sin 2s over 2, 0 to pi over 2. So this is pi over 2 into, put s to be pi over 2, minus, if you put s to be pi over 2 here, it will be 0. Sin 2 times pi over 2 is 0. And if you put s to be 0, everything is 0. Finally there, the answer is pi squared over 4. That will now be unit cube because we are dealing with volume. Another example, find the volume of a sphere generated by the revolution of this curve about x-axis on the s-intercept. If I want to draw this curve now, this is a circle, but it's half of a circle, which is semicircle. So that curve is a circle. So this is minus r to r. But by the time it's revolving, by the time it's rotating, this will come down too. It will look like something of this nature, which will become a sphere. So we are now looking for volume of a sphere, and we have no volume of a sphere before in our elementary mathematics, but we want to use integration to prove it out, to prove the volume of a sphere. And the volume we have said is pi a to b is rotated about x-axis, y squared dx. This is pi. Our a to b is minus r to r, minus r to r, r square minus s square. This is our y, all square dx. This is pi minus r to r. The square will cancel this square, it will remain r square minus s square dx. This is our pi. If you now integrate this, it will give me r square s minus s cube over 3. Minus r to r. This is pi into, if you put all this to be r, it will become r squared times r minus r cube over 3 minus, if you put all x to minus r, it will be r squared into minus r minus, this will be minus r cube over 3. So I will now have pi into, if you multiply this, it will give me r cube minus r cube over 3 minus, don't forget that this is minus r cube. There's minus here. It will become plus. The minus will cancel. It will become plus r cube. And this one, there's minus here. 1, 2, 3. It will become minus again. Minus r cube over 3. So this will become 2 pi because they are the same thing. They are the same thing. R cube minus r cube over 3. So this is 2 pi. If you simplify what is inside, it will give me 2r cube over 3. This finally will give me 4 pi r cube over 3. And that is, if you can still recall, that is formula for finding volume of a sphere. So we have used integration to find the volume of a sphere. You can see it once again. You can use it to find volume of a cylinder too. Question: find the volume of a solid formed by the revolution of the graph of the curve this on s-intercept about y-axis. The first thing is, when we sketch the curve, we solve that question. 4 minus s squared is equal to 0. S is equal to plus or minus 2. So definitely this is minus 2, this is plus 2. And we have negative s squared. So it will be maximum. It will go up like this. So this is a curve. But when it's revolving about y-axis, that it will be rolling like this. When it's revolving about y-axis, it will roll. It will continue rolling like this. It will form a circle here. And it will form a circle here. So this is the volume. This is the volume of, this is what we are looking for. The volume of the shape we are looking for. Sorry, this is the shape we are looking for, its volume. But since it's about y-axis, volume is pi a to b x squared dy. But what we are giving here is y. We are not giving x. So we only need to make s squared the zero formula. So from y is equal to 4 minus s squared. Making s squared the zero formula, s squared is equal to 4 minus y. So we substitute it here. Our volume will now be minus 2 to 2. It will not be, because it's it will not be minus 2 to 2 again. Sorry, it will not be minus 2 because we have changed it here. This place is now 0. 0 to is on y-axis that we are dealing with. To this place, minus 2 to 2 is for x-axis. We are dealing with y-axis. So this place is 0 because this circle is on this 0. But the question is, what is this place? How do we know this place? So we need to make this place, this thing, to be 0, so that at the end of the day, we want to know where it cuts, where this curve cuts x-axis. So we want to know where it cuts y-axis. Sorry. Don't forget that if we say that it cuts x-axis, we normally say y is equal to 0. That is the meaning of x-axis. If we say that y-axis simply means s is 0. So from that place, we have this function. We put s to be 0. Definitely y is 4. So in this place, y is 4 here. So it should now be 0 to 4. Instead of minus 2 to 2, it will be 0 to 4. S squared, this is our s squared there. 4 minus y dy. This is pi into, if you integrate this, we have 4y minus y squared over 2, 0 to 4. This is pi into 4, put 4 here, minus 4 squared over 2. This should be 16 minus 8, that is 8. Finally, our answer is 8 pi unit cube. So that is the volume of this solid.